hi, good morning. Thanks so much for joining me here in my shop for another session with that receiver. So I ended yesterday's video having corrected the problem I caused. Some bad soldering work in a tight area, hard to see. But what I didn't do was I didn't fully test the radio to see what impact changing 6 capacitors has had on the radio. I just was happy to hear it work, and that was enough for me. I didn't want to find out any more about it at that point. So we're going to find out more about it now. So everything is connected here, speakers and all. Okay. Here we go. So these switches are in the neutral position right now, and I think on this receiver what this means is it does nothing. There's an actual complete neutral spot here. Nothing going on at all. So we're going to flip it over to AM, and we're going to tune around and see what we can find here, if anything. So it's definitely tuning. And we're not likely to pick anything up at the higher end of the band anyway. So not receiving anything. It doesn't mean it's not working. It may be the antenna, which is sitting over here on the side of the radio. It just may not be in the right place to pick up stations for me here. I don't have a very close by AM broadcasting station. Okay, we'll go over to FM now. We'll check out the meter there. Let's look at this again, just a second. What's it doing way up there? The reason this meter is way up here is because the level of noise in my shop here is that high. No wonder I can't pick anything up in here. Okay, that's fine. Now we'll go FM. Meter's right up at the top. Uh-oh. Uh-oh. See, this is why I didn't go further with the testing. I've got a junky antenna there. It's a bit of a hiss. Wow. One weak station. Ooh, big pop when I did that. This meter's thrown over to the side the whole time, and this thing popped when I turned it off, and that's a hint of DC being somewhere where it shouldn't be. Not necessarily. I think I had the volume up pretty high during that. Yeah, I had the volume up pretty high, so that's probably what that was. Well, maybe not. Maybe not. I'm really not looking forward to having more problems in the radio. That would appear to be the case. Let me feed in a stronger FM signal that we can work with here. And how would I do that? Put a better antenna. Right now I'm just using this yellow piece of wire here. It's just on one side of the terminals. That's not the best way to do it. I'm going to fetch a real 300 ohm folded dipole antenna here. Okay, so what I've got here is it's a home built 300 ohm folded dipole antenna. Let me just cover those. I don't want those sticking out. So nothing more than 300 ohm flat lead with the ends shorted together, and then one wire opened and then connected to more 300 ohm flat lead coming down to here. That's what this is. This is the standard FM antenna so commonly employed by everybody everywhere. This single wire approach is really pretty sad in comparison. The receiver really is looking for a balanced antenna like this. Okay, well, I'm not so sure this is really going to make a big difference though, but we're going to find out. We need to prove that it wasn't just a bad antenna. And again, I'm not in the best location here. This antenna is not in the best location either. But unlike AM, there are local FM stations here. A number of them. There we go. Okay. So these antennas, like all antennas, are directional to some degree. Let's find out what happens here. Down, FM, I get the pointers right over, volumes right up. Ever so slight improvement, but exceedingly weak reception. So I got to think about things for a little bit here. Either this is indicating I've done another mistake on that board and it needs to be tracked down, or it's possible that the alignment of the radio now is required to bring it all back after changing components. A little surprised that would be the case. So I got to think a little bit about what I want to do next before doing it. That's what I'm going to do. Think. Okay, spend a few minutes thinking about my situation here. I have a number of options. The first option is just to go full bore, try to find out what has happened to the FM side of this receiver. Troubleshooting and whatever else that might involve. Okay, another approach is to do a little bit of poking around and troubleshooting. Maybe a little bit will get me there. Of course, how do you start a long journey? With a little bit. So maybe a little bit of troubleshooting and then some rethinking after that. The difficulty here is this is an FM receiver, and poking around with an FM receiver is not easy to do. AM, you can poke around with meters and equipment and not affect the radio too much. FM, not so much. Just about everything you do affects the radio, so you don't know what the true result of the test is. I have to manufacture a couple of special test circuits. I have to read up and learn a lot about the FM radio before attempting anything in terms of troubleshooting. Now, another approach is to make the assumption that this is an alignment issue, that the radio has gone way out of alignment. That's a tough stretch too, a little bit of alignment, but this appears to be way out. But I could go through the alignment process a bit and see if it doesn't cause a dramatic improvement. Could do that. I need to learn the alignment process anyway. Obviously it's going to have to be done at some point. Another approach is I ignore it all, pretend it doesn't exist, carry on with the amplifier and the basic process of bringing the amplifier into better condition, which amounts to changing about a dozen electrolytic capacitors on that board. That doesn't sound like a very good idea. A, ignoring the problem doesn't make it go away. Number two, if I go ahead and change all these capacitors on the amplifier board, there's a chances are I'll have two boards not working. And that's probably not a good idea. So ignoring this, not a good idea. Another thing I can do is hook up a piece of test equipment and drive a stronger signal into it. I have to do that anyway for alignment purposes. What would that prove? That wouldn't prove too much. So it kind of boils down to whether I think there's a component problem that needs to be found and replaced or dealt with, or whether it's simply really bad alignment. So the alignment thing, I'm attracted to fool around with that a little bit at this point. They may discover it's all alignment. If it is, then me trying to do troubleshooting, all that kind of stuff, a big waste of time. So maybe I can do some stuff to quickly discover if it's an alignment issue. I kind of doubt that, but I don't know what that would be. I have to go through the alignment process here. It's for an FM radio. It's a little complicated, and it has to be done with a fair bit of care. Another thing is to do signal tracing and to determine if the signal is getting anywhere in this radio. Maybe the radio's receiving and processing halfway, and then something's going wrong, and maybe I can figure that out. So that's another option, is to do signal tracing. Again, in an FM radio, that's a bit of a problem. Oh my gosh. Well, if we're going to do alignment, we're going to need a piece of test equipment running anyway. So why don't I do this? I'll get that piece of test equipment you see down there going, hook it up to the radio, be able to put a strong signal into it, and see what we get out of that. I think that's the approach I'm going to take to start. Start by doing as little to the radio itself as possible. Yeah, or I'm going to make more trouble. Okay, so I've removed the antenna and connected the signal generator to the antenna input. This signal generator comes with a little resistor pad network here. So although the documentation for the radio comes with a circuit specified for that purpose, there's one already here, so I don't have to deal with that. So this guy will be transmitting at 100 megahertz. So we'll go FM, so that needle will drift over, 100 in the middle. Whoa, 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 whoa. I thought it was in the middle. Here, yeah. That's interesting. Okay, let me turn down the level here. RF levels turn down quite a bit. So I know what's happening with this meter now. So this meter should be sitting in the center, and as you tune, it should swing back and forth, come back in the center when you get right on the station. The current center for this meter is over here, and so it's doing the swinging properly, but it's doing it way over there. Come on, don't prove me wrong now. Yeah, it's swinging around this point, so that's an alignment issue or an adjustment issue. very well be causing a lot of trouble, having this sitting like this instead of sitting in the middle. The cause of it, not the meter itself. So we got a nice strong signal coming from the signal generator. Let's tune it in now. So you can clearly see something is wrong with the way this radio is aligned. There should be a very symmetrical process tuning through a station. Should just give you a very symmetrical. This doesn't. And it has this very sharp sound in it there. Meter's way off center. It's all screaming, align me please. Now what about the stereo light? So the subcarrier level is very low. The 19 kilohertz is very low, so we don't see the light. We don't see the light. Tune it in. I think I'm tuning it in. Well, it's hard to say because it's so whacked out. Okay, so I'm going to turn on the 19 kilohertz. So turn it on. I'm going to turn it up. It's full now. Audio mono. Stereo left, stereo right. Did that turn the light on? No. Okay, I'm just trying to be absolutely sure I've got everything set the way it needs to be set. Let's tune. Is the light flicker? Right there. The radio's working. This gives me the impression now that it's weak and out of balance here because of alignment issues. So I'm encouraged, forget about looking for a bad component or a mistake in the work I did. Carry on with the alignment process. That's what all this says to me. So now I got to read this very complex alignment process and prepare to do it. I don't know if I'm going to get that done today. Well, we can get a start into it anyway. Okay, I'm going to study up here. Okay, just a small aside here. The receiver is turned off, and I found something here I'm going to poke at. I thought I'd do it on camera. So I look in at the transistor down there under the green wire. I see something laying across the leads. It's probably just a piece of paper or something like that, but could it be a piece of metal? No, it's just paper junk. Well, okay, so I'm continuing with getting ready for, I'll show you what I'm doing here and what I'm up against, to try to do some kind of reasonable alignment work on this radio. Very challenging. So it's looking for a test probe that won't disturb the sensitive FM circuits. That's what I've got here. This is an RF probe. It's not intended for this particular scope lead, but I've got it jury rigged onto it. In here is pretty much the circuitry that the alignment instructions are specifying, but not exactly the same. RF, IF, VF signal tracing probe. And what this does, this is basically a detector circuit in here. Is this going to work? I don't know. That's number one. Number two. What is number two? Number two is where is the test point I'm supposed to test? That's what I was in the middle of looking for when I encountered that piece of debris. The test point, I would expect it to be something sticking out. Maybe it's on the back side. I believe it should be right down in between here. Maybe it's back here. Right down in there. Oh my gosh, I don't know. Yeah, that's what I'm up against. is going to be a while here. Okay, I think I've identified test point 1 here. And it's this, probably hard to see in the camera, but there's a fairly long wire sticking out here that's been doubled over and looped back. And why would they do that? To create a obvious test point. It looks different than everything else. It's in the right position. That's got to be the test point right there. Son of a gun, there's another thing here right beside it. Oh, 2 test points right side by side. Wait a minute, that's the same. Hang on a second here. What's going on? Where's my camera? Here it is. What's happened to the focus here? Here we are. So no, the 2 test points I'm looking at down at the bottom there are on different parts, different sections of the board, different traces. One to the right, one to the left. Oh my gosh. Okay. Which one of those is it? It's not clear in the manual. Oh boy. Okay, manual. So we can find test point 1. Well, I'll show you how they mark it by showing you test point 2. Test point 2. See, they write it in a bubble, and then they point to a spot. They write it in a bubble. So where's test point 1? Okay, so we'll look at the other part of the board here. There it is. Test point 1, right on the border of their copy. And what exactly is it pointing at? I can't tell. So here's the edge of the transistor and one of its terminals right here. You see the edge of the transistor is actually missing on here. It's right here. That's got to be it, right there. Now, I'm seeing 2 test points. The other one would be on the other. Would be here. No. Wrong board. One is here. The other one is just not showing at all. Well, one of them looks a little more obvious, like a test point, and the other one looks a little more like just the way they did the work. Son of a gun. So it's got to go to this. It's got to go to the what looks like the base of. Looks like Q20 something. It's just nothing is easy here. Hooking up to the wrong spot shouldn't really cause a problem with a high impedance oscilloscope. Interestingly enough, the circuit that they recommend you build to do this starts off with a 100 ohm resistor, which would find itself between the test point and ground. That's kind of odd, isn't it? A 100 ohm resistor on something like this. But that's what they show. Okay, so we think we have the test point. Well, after a little bit of searching, I found all the components needed to make up one of the circuits that's specified in the manual. So this is the circuit you use to go between your scope lead and the test points in the radio. All I got to do is just solder this thing up and maybe solder it right into the receiver. So it's kind of semi-permanent in there. I won't have trouble with it that way. There we go. And the diode, it's a little hard to see. There's a germanium diode right in there. The diode they're calling for is a AA119. This is a AA112, which apparently is a perfectly good substitute. So that's what I've got. I couldn't find a AA119. There we are, though. I think that's going to work. Okay, built the finished circuit here. I'm going to try clipping it in. The set is off right now. Something just popped. I don't think the clip is soldered right on there. can't touch it. Something else is moving. This is moving right in here. How can it move like that? Looks like I've got solder on this wire, but not solder on the lead. That's what it looks like. Boy, oh boy. You'd think for a guy who's been wielding a soldering iron for, would be 50 years easily. You'd think I'd be able to solder something, but apparently I can't. When I was working at the power company, and they'd bring in a new engineer or somebody new, and I'd be chatting with them, and at some point I'd say, "Do you want a soldering iron?" Based on that answer, I made a big judgment about that engineer, because almost always the answer was, "Why would I want that?" Meanwhile, I'm living my life pretty much soldering something every other day. Well, now I solder something every day, but back then. Okay, we're ready now. At least just to clip it on here and see what happens. So you want that to be fairly steady. I have the feeling I'm going to be using this a fair bit. So now we want to clip on a scope lead, or attach a scope lead. Let's try. So the scope lead is supposed to be here and here. So I think what I'm going to do is I'm going to shorten this up quite a bit. I don't think we need an antenna sticking out like that. And I'm going to get caught on it, hurt by it. There we are. That would be the setup. This is on times 10 right now. That would be the setup. And should I try this out? Something wrong here. There needs to be a connection from the bottom to the ground. It needs to be another. I need to attach another lead onto it. Grounding lead. Okay, I will do that. Okay, attach the ground lead. Let's attach this again. Now, right in the manual it says, do not make and break connections, test equipment connections to this guy with the power on. It actually says don't do that, so we're not going to do that. So I'm going to put this here, and then this can go here, I guess is okay. Okay. Now, what is going to happen here? It's a good question. So we're only showing this channel, the one we're operating here, and don't know what voltage to expect here. 1 volt per division now, and we're on times 10 here. Times 10 on the probe. Okay, you know, my normal practice would be to operate the unit and then make and break the connections of the test equipment to determine the effect of the test equipment on the radio. And in this case, it's saying don't do that. So we're just going to start like this, and we'll just have to hope it sounds kind of the same as it did without this connected. So I still have the signal generator going. Everything is the same. We're ready to power on. Switched on FM. Radio switched on. Volume down. Power on. Okay. Nice hum. Tells me everything's okay, maybe. Volume up. Volume up. Okay, volume's way up to get that to come out of the speakers. So maybe we're out of tune here. Tuning? Yes, I would say that's out of tune. Nothing happened on the scope though. Okay, volume down, down, down. Listening to the buzz. For a minute I thought the buzz was coming out of here. No, the volume down a bit here. Okay, so we're seeing absolutely nothing on the scope. That's not very reassuring. What are we supposed to see on there at this point? Or am I not on test point 1? Maybe I'm not on test point 1. Maybe my circuit didn't work. Maybe. Too many maybes. Let's go on to times 1 here and see what effect that has on the radio. Okay, so now with times 1 I'm seeing a little bit here. It looks nothing like what I would expect though. You can see a little bit of there's some noise. It looks like noise in here. Okay, I'm going to tune back and forth here a little bit. They make absolutely no difference on the scope. Why are you doing that? Okay, so I have the scope set to AC here. I'm going to flip it over to DC. Let's try now. What are you supposed to do with that? Well, you can see the effect of the diode. I'm pretty sure the diode in my little circuit is chopping everything off below here. And this just looks like, it just looks like noise to me. I mean, I don't see any kind of signal there. Let's flip this over to AM. Just see what happens here. Oh, it's still there. Exactly the same. It's just crap. It's just crap on here. This is crap. So lots of volume in the AM part of the radio. Now there's a lot of circuits specific to the AM part, and the FM signals running through different circuits. So knowing that the AM circuits sound strong and good, it doesn't help you much with the FM side of it. Well, I think I'm going to stop here at this point. You can see by the clock it's almost noon. I got to think a little more about this. I mean, I knew when I started into using one of these circuits that sooner or later I'd be troubleshooting this thing itself and trying to sort all that out. I think I may not be on test point 1. I think that's what... Well, why don't we just move it over? Let's move it over. So power off. Nothing. Look at the scope. It's doing exactly the same thing still. Finger test. I'm not doing much to the scope either. That is. You know, I didn't bother testing the diode. The diode's brand new. Okay, so the test point, it could be right here. It could be right there. We get the same result on the scope right now. I'm going to desensitize the scope input, put it on times 10, make it a little less sensitive, put the power back to it. Well, we see something different this time. And volume up. Oh, I have got this in the neutral position here. Okay, so FM. Lovely. So whatever we're getting on the scope, not volume sensitive, that makes sense. Volume's happening down in the amplifier, it's not happening up in the radio. What are we supposed to do with that little signal? Let's put this on times 1. Ooh, now we got something strong here. Now we got something interesting. Now, one of the difficulties with my oscilloscope here is it won't trigger properly, or it seldom triggers properly. So I doubt we're going to get it to trigger. Which means it won't stop. So what I do is I cheat. I'll use this control to kind of stop it. So yeah, you can see in the camera what we got there. We've got a sine wave with a whole pile of hash in it. I'm going to tune the radio and just see, is this really coming from the radio? Where's it coming from? Tune in the radio. Oh yeah. Oh, that's a good result. The DC part is interesting. Watch as the scope goes up. Oh, that's good. That's got lots of fanciness in it. My guess is somewhere. Yeah. I think that's going to work. Doing something anyway. That's good enough. Good enough for today, I think. That's kind of interesting. The set is grounded through the oscilloscope. I think there's a chance this is picking up noise and injecting it into the radio. Well, we're going to leave it like this. Leave it like this, and oh, it's touching this. Leave it like that. Carry on tomorrow, trying to figure out what is going on. So thanks for watching. It's a bit of a slow process here. I'm trying to be as careful as possible so as not to cause problems, just like I did a little while ago. So okay, see you on the next video.